So now we've seen adding and subtracting, so we'll take a look at polynomial multiplication. We will start with the simplest case because once you understand this one rule, this one scenario, you officially can really multiply any polynomials together, any size. The idea, multiplying a monomial times a monomial, we've actually already seen this. This problem showed up back in section 5a. The idea that when you multiply a single term times a single term, it is all multiplication, so you can reorder it if you needed to, but most importantly we saw it means you can multiply the coefficients, the numbers, 2 times 3 giving me 6, that 2 times that 3, but then x squared and x cubed, this is a multiplying similar basis, so you add the exponents, giving me x to the 5th. So again, multiply coefficients, add exponents of same basis, and you've got your result. That's all we have to be able to do when multiplying any size polynomial because the key is just understanding how to distribute. Now, this word to us has meant something since we learned it back in chapter 1. And we're just going to slightly tweak it here on this page, but then we'll adjust it more for other examples to come. So, the slight tweak, the slight difference between what we see in the past and what we're seeing now is that the thing you can distribute can have a variable in it. That's something we've not seen. We've seen numbers, we've seen negative signs, we've not seen a variable out front, but we know what to do. We know how to do it, I should say. Whatever's out front, I'm just going to circle it, it's 2x. That gets distributed through both these terms because these terms can't be combined, right? We could look inside parentheses, but there's no like terms. So as you distribute, I'm going to write this first one out. This first arc represents 2x times 3x squared. Okay? Now I'm going to use this minus sign just to separate that arc, that multiplication, from the next arc. So since I'm using the minus sign there, I'm going to bring in the 2x times the 4 that was there. So we don't want to lose any signs, but we can keep track of it that way simply enough to see the multiplication, to see the distribution to get to there. Now we can do the multiplication. 2 times 3 is 6, and x squared, remember that's x to the first, so 1 plus 2 is 3. Minus, now here, this doesn't have an x at all, so it's just 2 times 4 is 8, and we bring down the x. And then, when you're here, you're done. Because once you've distributed, the only thing else you would do is combine like terms, but those are not like terms, right? X to the third and x to the first are not the same base with same exponent, so do not try combining those at all. You're done. All right, same thing for the next one, except I'm not going to write out that second step because it can almost get confusing potentially with all the minus signs especially. I'm just going to draw one arc at a time and do it one term at a time. I'll draw this first arc. This is negative 3x squared times 2. Well, negative 3 times positive 2 is a negative 6. The x squared, and there's no other x squareds, so just x squared. That's that first arc. The next arc is negative 3x squared times negative 3x squared, right? That minus is a negative sign on there. Negative 3 times negative 3 is a positive 9. Now here, you have to remember, you're multiplying x squared times x squared, right? We're multiplying similar bases, so we're going to add the exponents. Don't look at x squared and x squared and think they're like terms. That's not what we're doing here. We are multiplying those bases, and so we will add the 2 and the 2 to get that x to the 4th there. Same with the third arc. Negative 3 times a positive 4 is a negative 12, but then x squared times x, so x to the first, x squared times x to the first is x to the third, right? 2 plus 1 is 3. And arguably, that is it. That is done. You've distributed, cleared parentheses. Notice there are no like terms, second, fourth, and third. Whether or not you put that in what we call descending order is, technically more organized form of it. Descending order would be putting the highest power first, so the positive 9x to the 4th, then minus 12x cubed, and then minus 6x squared. Notice 4, then 3, then 2. That's not required, though. There's only one place in this chapter where that's absolutely necessary, and we'll get to that eventually. So that is a perfectly fine final answer there.